I am, my name's Simon de Toit. I'm from South Africa, Cape Town originally, born and bred, and I'm currently studying a computer science degree at Stellenbosch University, the heart of the Winelands. My current passions and focus include natural language processing, evolutionary algorithms, and swarm intelligence, so a couple of cool things that I'm doing there. And the basis of these slides and what I'm going to tell you about today is actually the project that I was tasked with in the beginning of this year for the final year of my degree. And it seems that it's been quite relevant because it's with COVID-19 especially, there was that White House challenge where they talked about the need to be able to structure the bibliometric data and to be able to pull out relevant information for researchers to really do some quality research on COVID-19. And my project actually extends to the notion in general that the number of papers being published every year is significantly increasing. And just as an example, I just posted an open access articles graph just showing that the number of papers that have been increasing between 2006 and 2016, you can just see a rapid increase. And just why is this? Why do we have such a rapid increase in just the sheer number of publications? And the first is due to the rise of open access publishing. Publishing online is now becoming freely available. Everyone can use it without having to pay, premium subscriptions, stuff like that. And also the notion of publish or perish, where in the academic system, researchers currently around the world are being pushed to publish. I wouldn't say subpar work, but probably not the best quality that they could produce, quantity over quality. And so just moving on, how do we solve this type of problem? How do we get around it? How do we find relevant papers? So that's kind of the task that I was asked to try and solve. And the first thing is natural language processing. Definitely becomes an important part. I used a couple of unsupervised learning techniques and also most importantly graph algorithms and how graph is able to solve this specific problem that I've been having. So the implementation overview, what I've currently done so far, as it's still in a work in progress, but this is currently, the couple of things that I've done. And the first is TF-IDF Vectorization. The second is PCA Dimensionality Reduction, which just reduces the vectors. I used the k-nearest neighbor machine learning algorithm. I then, had a TigerGraph as the backend database side and used GraphStudio with that. I implemented using one of the G-SQL algorithms, the Jaccard Similarity algorithm, and then I used Plotly's Dash to display in the front end, and also for the 3D visualization part, I used iGraph package for that. So TF-IDF just stands for Term Frequency Inverse Document Frequency. It determines how important words are to a document given a set of documents. So just as a little representation on the right, we can see that, I'll just go through the first word is complexity, pops up in papers D1, D3, and D5, and it's given a score. So D3, the word complexity to document 3 is more important to document 3 as it is possibly to document 1. So that's just a bit of an explanation on how term frequency inverse document frequency is, and it's super important because we need to be able to quantify and be able to do some mathematical calculations on papers, and we have to have some representation of that. So it's a really cool idea and good idea to turn these papers into a vector format. Moving on, the problem with TF-IDF vectorization is that it returns a hell of a lot of feature points. And we have to limit those feature points to some extent, and then also a lot of noise is introduced when doing that. So what PCA Dimensionality Reduction actually does is to solve the curse of high dimensionality, where we can keep core information while reducing the noise within the feature vectors. So after I've done all of that, then I implemented the k-nearest neighbor algorithm on these vectors, where generally it's a classification algorithm, but I kind of use the byproduct of it, where I compare the vectors to each other via some sort of similarity notation, which we can do with vectors, to be able to pull out similar papers to the current paper you're possibly looking at. So that's kind of the thought process behind using the k-nearest neighbors algorithm. Then the number of papers, before I get to the TigerGraph part, I can just talk a little bit about, I have a data set that's 155,000 full-text papers that include abstracts, titles, authors, and concepts. And after doing all the pre-processing of all that information and storing it in such a way where it would be easy to upsert it into TigerGraph, is what I had to do originally before actually being able to do some of the algorithms for it. So with TigerGraph, the reason why I use TigerGraph is because it's enterprise, it's natively parallel, and it can be used for analytics. It's an analytic platform. And especially because it has a cool feature of the real-time deep link analytics, which is also really important, which comes part of the Jaccard Similarity algorithm. And GraphStudio is the user interface used for TigerGraph, and that was used, I'll also show you a little bit in the demo, how I was able to install queries and be able to visualize the data before actually having to really plot anything. It has some built-in features there. Moving on to the Jaccard Similarity. So what do I mean by Jaccard Similarity? Well, there is an equation here that represents it, but more so just saying that we can find similar papers to one another in the context of bibliometrics by seeing the number of concepts that two papers have in common and the number of authors that two papers could possibly have in common. So that's kind of what this similarity algorithm actually does under the hood. And to wrap that all up, we used Plotly Dash to display everything in the front end and to be able to see the visualizations, to be able to just have some sort of software engineering application where which I'll show you in a minute. Then finally, I used iGraph for the visualization tool, where I used a 3D visualization of being able to, so that you can explore complex graphs, and that's what we're going to do in a little bit as well. So the issues I've had and some future work with regards to the issues, the nearest neighbor algorithm wasn't implemented on the database side. It was actually implemented locally, and that can hinder the performance in real time because after the model was fitted and then a couple of predictions are made, it does take a couple of minutes to run the entire algorithm, which is why a lot of it is just currently sitting locally, and it's also about 6 or 7 gigabytes that it was also quite large and can't just kind of sit on the server itself. And the second part of the project that's been a little bit of a difficulty is how do we quantify the performance of the application? And by that I mean there's no real way of saying, are we returning correct results? Are we returning accurate results? And that should come through more of a user study and a use case, kind of mentality. So the future work that's going to be currently done is there's a landing page, concepts page, and an author page where you'll be able to navigate and select papers and select authors and concepts. And then the second is to construct a concept hierarchy. So, some concepts may be more scope than others and will fall underneath a kind of, greater heading. The introduction to more GSQL algorithms. So, for example, we can still use PageRank, we can use community detection, we can do a hell of a lot more algorithms and add it and really, have a very complex and a rich user-enriched model that we can create. And finally, similar to search engine optimization, we'll use Spaces semantic linking for some search functionality where you'll be able to type in you know, a sentence or a couple of keywords of something that you're looking for, and some results will be returned to that. So without further ado, let me hop onto the demo side. So as you can see, I just want to make sure that everyone can see my screen on the right, where, yeah, we have some authors that have been returned. So this is a specific paper called Expressing and Optimizing Sequence Queries in Database Systems. And what we're currently seeing here is the nearest neighbor algorithm, so which is only context. It's not based on concepts or authors, which actually are in the database represented as vertices. And so in this visualization, we can see that we have a 3D model where we can explore, but in this example, you know, maybe the visualization is not as useful, but if we had to go to the Jaccard Similarity algorithm, we can see a lot more detail in terms of what's returned, where, for example, here the blue node is the source node of the current paper that we're on, and these yellow nodes that are around it are all the similar papers that are also returned in the top matches column on the left here. And so we were able to see, you know, why kind of these papers are similar by exploring and traversing the 3D visualization of you know, what's happening with the Jaccard Similarity algorithm. And the pink nodes in this example are authors, and we can see that this blue node and this yellow node are connected via these three authors. And we can also see that these concept nodes in the middle is also, you know, how they are connected. So that's kind of a little bit about where I'm at so far, what I've done so far. I've done 2 different types of algorithms, and just having, you know, a really nice, neat front end to be able to display everything. And to wrap it all up, the main reason behind this is, you know, to have some sort of user functionality where for example, the hypothetical situation, if I have a paper, and specifically this paper, that I find relevant, I enjoyed it, I used it, I cited it, and now I want to find similar papers, you know, maybe dive deeper into the topic that I'm currently researching, and how would one do that? Well, with these top matches and relevant papers that get returned via the deep link analytics, we can really, you know, optimize and efficiently search for relevant papers in this way.